Hello, 7th grade math students. This is our first online math lesson. Today we'll be taking a look at lesson 56, which is plotting functions. So a function is a mathematical rule that describes the relationship between two sets of numbers, an input set and an output set. So to put this more simply, a function is just something mathematically we're going to do to an input. So something we're going to stick into the function that we're going to do something to it. And then after we've done something to it, we're going to get something out. So the group of all the things that we can put into the function is called the input set. The group of all the things that result or come out of it are called the output set. So functions can be represented in words or by equations, graphs, or function tables. So as a function table, the left column is always going to be our input. The next column will always be our output. Now, when it comes to graphing, the input is often our x value. Not always, but often. The output is often our y value. Again, not always, but often. We could use other variables as well. So let's just make up some pairs here. So let's say we stick in A and we get out B. We stick in C, we get out D. Stick in E, we get out F. We stick in G, we get out H, and we stick in I, and we get out J. Now our function table is going to result in these pairs of values. Well, these pairs of values can make a coordinate pair, which then we can graph. So if the input is A, that's going to go in the X spot first. And if the output is B, that's going to go in the Y value spot, that's second. So A input, B output becomes the point A comma B. C input, D output becomes the point C comma D. Likewise, this will become E comma F. This would become G comma H. And this would become I comma J. So since we can graph these, let's do a quick review about graphing. So if we look here, we've got a coordinate plane here. We got a nice grid going. So remember that the coordinate plane is made up of two number lines. So my first number line here, I'm going to draw horizontally about in the middle. And then my second number line, I'm going to draw vertically about through the middle. And since these are lines, they do go on forever, so we do put arrowheads at the ends of them. The horizontal number line, called an axis, is called the x-axis. And as it heads off to the right, we consider, since most of us are right-handed, it has been decided that that will be the positive direction. So this line right here would be 1, where this line, this grid line comes through, that'd be 2, this would be 3, 4, 5, heading off in the positive direction. Where the vertical axis hits the horizontal axis, we consider that to be 0. So you can treat this vertical axis like a giant tick mark, that's 0. So heading off to the left then must be the negative values, -1, -2, -3, -4, -5, and so on and so on. So again, this is the positive x values. This is the negative x values. And we typically, if we're going to label this axis, and this is what I'd like you to do, we often label the x-axis in the positive direction. So I'm going to put an X next to this positive x-axis direction. The vertical axis, as you probably are recalling now, is the y-axis. So as we go up, up is considered the positive direction. So 1, 2, 3, 4, 5. So down is the negative. Now make sure that you do not skip any of the grid lines. One of the common mistakes that I see students make is because we're putting our labels down here for the x-axis, it feels too close right there, and so a lot of students will skip that tick mark right there. Don't skip that tick mark. If this is where they cross, this first tick mark is -1. So as we said, this is the positive y direction. This is the negative y direction. And likewise, if we're going to label this axis, we often label it in the positive direction, which again is what I would like you to do on the homework. So when it comes to graphing, if we want to graph a point, the values are alphabetical. So the x values will come before the y values, just like we saw over here. The x values come before the y values. So if I have this point right here, we would look and see that this lines up first with what on the x-axis, while that point right there lines up with 4 on the x-axis. Next, I would look at where does this line up with the y-axis, and it lines up with 2 on the y-axis. Remember that all points are surrounded by parentheses. So just a reminder, x value first, then y value. If I were to have a point, let's say, right down here, likewise we would see where does this line up with the x-axis? Well, it lines up with -3 on the x-axis, and then it lines up with, on the y-axis, -5. So -3 comma -5 is my x value and my y value. So let's take a look at an example of a function. There are 2 chairs at each table. Make a function table for the relationship, then graph and write an equation as well. So first of all, we have to consider what's our input. So what is the thing that you would be counting? What's the thing that would be causing the other one? So in this case, you're not likely to just have chairs. No, you're going to have tables, and then you're going to put a certain number of chairs around them. So the input here would be the tables. The number of tables will affect the number of chairs. If I don't have enough tables, I would probably put some chairs away. But if I have tables, I'm going to go find some chairs to put around them. So tables will be my input, chairs will be my output. So that means that the number of tables is basically going to be like our x value, and the number of chairs will be our y value. Now if we consider our input set here, what could the number of tables be? Well, you could have 0 tables. You could have 1 table, 2 tables, 3 tables, 4 tables, or even 5 tables. So then from here, if I have 0 tables, that will be 0 chairs. If I have 1 table, we're putting 2 chairs at each of them. So 1 times 2 is 2. 2 tables, 2 times 2 would be 4 chairs. 3 tables, 3 times 2 would be 6 chairs. 4 tables, 4 times 2 would be 8 chairs. And finally 5 tables, 5 times 2 would be 10 chairs. So this produces the point 0, 0. This would be the point 1, 2. This would be the point 2, 4. This would be 3, 6. This would be 4, 8. And finally this would be 5, 10. So now if we go ahead and graph these, this time instead of finding their coordinates, we're going to be using their coordinates. So I'm going to do a quick label here. Again, make sure you don't skip any of your grid lines. So 0, 0 is nice and easy. This is just going to be where they meet. So 0, 0, remember, is called the origin. So I put a dot there at the origin. Now 1 comma 2. Remember the first value here is the x value. First value is the x value. So I'm going to find on my x-axis, there's my x, there's my y. I'm going to come over here to 1 on the x-axis. The second number is my y value, 2. So I'm going to just go straight up from here till I'm lined up with that 2. So this point is lined up with 1 on the x-axis and 2 on the y-axis. So there's my 1 comma 2. To graph 2 comma 4, 2 will be my x value. So I'm going to come over here to 2 on the x-axis. And then I'm going to go straight up till I'm lined up with 4. And then we can get 3 comma 6 on there. So 3 is my x value. And then straight up to 6 would be up here at the top. So that's going to be the last one that I can get on this graph. Now, can we go negative? Can we have a negative number of tables? No. So this actually will start right here and will continue to move forever in this direction. Now here's what we got to consider. Can we have half of a table? Can you have a third of a table? Can you have 1.5 tables? Not really. So we cannot connect the dots here. Instead, what we're going to do to say that this keeps going on forever is we're just going to put an arrowhead there to say keep going with those dots in those directions on for forever and ever and ever. So that actually will be our graph this time because it's a real world problem where we can't have fractions or decimals. Now for our equation. We're going to take a look here and consider what's happening. Now this should be pretty obvious. We just took the number of tables, we took the x and multiplied it by 2 in order to equal the y. So we start our equations with y equals, so we kind of flip it around. So this is basically saying in order to get the output, in order to get that y value, it's going to require you to do what? Well, 2 times the x values we write as 2x. Now the relationship between the equation and these things is that if we stick these pairs of values in, or if we stick the coordinates of any point in here to this equation, it should make the equation true. So if we do a quick check here, if I start with 0, 0, so we know that y equals 2x. So this first 0 means that x is 0. This second 0 means that y should be 0. So if we simplify this, well, obviously 0 is 0, and then 2 times 0 is 0. Well, does 0 equal 0? Of course it does. That checks out. If we check 1 comma 2, so again our equation is y equals 2x. This means this 1 here first means that that's my x value. So this is 2 times 1. And this second number means that y is 2. So does 2 equal 2 times 1? Well, 2 times 1 is 2. Does 2 equal 2? Yes, it does. If we check 2 comma 4 real quick here, same idea. So our first number here is the x value. So we're replacing this x with that 2. So 2 times 2 over here. And then the second number is our y value. Replace that y with 4. So 2 times 2 is 4. Does 4 equal 4? Yes, it does. And we could continue to do this with the rest of these points. And I think that you can realize, I hope, that these will all check out. So this equation does truly work to describe both this table and this graph. So let's go ahead and flip our papers over here. And we're going to take a look. This time, instead of starting with a story problem, we are going to start with a table of values. So for my table of values here, given the table of values below, graph the function and find its equation. So there's my table value. So remember, I'm not going to write these all out this time. But remember, this is going to be my first number, comma, my second number. So when I make my coordinate plane, oops, yeah, need to fix that a little bit. So 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, up 1, 2, 3, 4, 5, down, don't skip any tick marks, and -5. Remember, we're going to label the x in its positive direction, we'll label the y in its positive direction. So here we go. So our first point will be -3, -5. So the x value is -3, the y value is -5. So I start with the x value. So I'm going to find -3 for the x value, and then down to -5 for the y value. That's my first point. My second point is -2, -4. So I'm going to start with -2 for the x value and go down to -4 for my y value. -1 for the x value, followed by -3 for my y value. And then 0 tells me just stay right where I'm at as far as the x-axis goes. But then I'm going to drop down to -2 for the y value. And then I have a +1 this time for x, but then down to -1 for y. Then we go right 2 here for my x value, but the 0 there for the y value says stay right where you're at as far as the y value goes, so no up or down. Finally, over 3 for the x value and up to 1 for the y value. Now, since this doesn't have any story problem going along with it saying that all the values have to be positive, like you can't have negative tables and negative chairs, since we don't have any of that, we're going to connect all the dots here with a line. And since this is a line, it will get arrowheads on both ends. Now, if we consider what's happening here, if we look at 3, how do you go from a 3 to a 1, a 2 to a 0, a 1 to a -1, a 0 to a 2? Hopefully you're seeing a little pattern here. This one should be a little bit more on the obvious side. Maybe not so much in the negatives, you might be a little less comfortable with those, but especially here on the positive end, it should be a bit more obvious. This one, all we're doing in order to find the y value is we're taking the x value and subtracting 2. Now, if you think that that's what the equation is, remember that red pen means what we should be thinking. So if -3, -5 is one of my points, it means I should be able to plug those values into the equation, and it's true. So let's consider. So -3, -5. So the -3 would be the x value. So if I take -3 and I subtract 2, it should be -5. Well, if we're at -3, so consider if we're at -3, and then I go 2 more in the negative direction, that puts me at -5. So sure enough, that checks out. If I try this with, let's say, 0, -2, something a little bit easier. So if I take my y equals x minus 2. So this is my x value, so 0 minus 2 should equal -2. -2 is the y value. Well, 0 minus 2, well, if we're at 0 and we minus 2, that is -2. -2 does equal -2, that checks out. Probably one of the easiest ones to check. Let's try 3, 1 real quick. So y equals x minus 2. Our x value this time is 3, so 3 minus 2 should equal 1. Well, 3 minus 2 is 1. Does 1 equal 1? Yes, it does. That actually is my equation. Moving on to example 3. Given the equation below, make a function table and then graph the function. So this time, here's my equation. So what I'm going to do with this is I'm going to make this x, I'm going to make that y, and now I'm just going to choose some values. So a good idea here for values is to put 0 in the middle and choose a few numbers on the left side of your y-axis and some on the right. So some negative and some positive. So I'm just going to make this real simple, -1, -2, and then +1, +2. So what we need to be thinking about here is then the y value is going to be 3 times -2, and then we're going to -1. The y value here is going to be 3 times -1, and then -1. 3 times the x minus 1. Here, it'll be 3 times 0 minus 1. This will be 3 times 1 minus 1. So this 1 right here comes from the x value, because it's 3x. And then this 1 right here comes from the fact that it's a -1. And then finally, 3 times 2 minus 1. So 3 times -2 is a -6, minus 1 is a -7. 3 times -1 is a -3, minus 1 is a -4. 3 times 0 is 0, minus 1 is -1. 3 times 1 is 3, minus 1 is 2. And 3 times 2 is 6. 6 minus 1 is 5. So to graph this, my first point is going to be -2, -7. Now if we consider the space that I provided for you here, make that x, make that y, we've only got room for 6. So actually this one here, because of that -7, is actually going to be off my graph. So we're not going to have to worry about graphing him. He's just outside of the space that we have. Obviously, if we had a bigger graph, we would graph him, but I didn't give you a bigger graph, and that's okay. So we'll start with -1, -4. So -1 is my x value, and then go down to -4 for your y value. Next is 0, -1. So 0 tells me stay right there on the x-axis, but -1 for the y tells me to go down to -1 for the y value. 1, 2 tells me go to 1 for my x value and up to 2 for my y value. And then finally 2, 5 tells me to go 2 for the x value and then up to 5 for the y value. And since there's no story problem suggesting they can't have fractions or decimals, we connect it with a line with arrows on each end. So, last one, example 4. Given the graph, so this time I've given you the graph, make a table of values and write an equation for the function. So I'm going to go ahead, I'm going to call that x, I'm going to call that y, I know that much at least. But what I'm going to do here is, we know that this is the positive x value, we know this is the positive y value. I'm just going to look at this line here, and I'm going to look for spots where this line nicely crosses my grid lines. So as I look at it, right here is a point where the line nicely crosses my grid lines. If I move over here, here's another point. There's a third. Here's a fourth. Here's a fifth. And there's a sixth. And now I'm just going to take those values and I'm going to put them into my table. So first of all, if I consider what are the coordinates of this point, well, this point lines up with, well, if it's right there, that's -1, -2, -3 for my x value. And then down here, right here, would be -1, 2, 3, 4, 5, -5 for my y value. Oops, sorry, my paper slipped there. If I move on to the next point here, this one lines up with -2, and I'll go ahead and label that -2 then for my x value, If this was negative 5, this was negative 4, so then it lines up with negative 3, oops, negative, for my y value. So this would be negative 2, this would be negative 1. So this point right here lines up with a negative 1 for my x value and a negative 1 for my y value. So that's negative 1 comma negative 1. Going up here now, I'm going to go 1, 2, 3, 4, 5. And so obviously we didn't move left or right on the x-axis. So this is going to be 0, comma, and then we have to go up to 1 on the y-axis. 1, 2. So this next point lines up with 1 on the x-axis and 3 on the y-axis. And then finally my last point lines up with 2 on the x-axis and then lines up with 5 on the y-axis. Now if you've got all that, it's real simple to throw it over here then. Just take this point and split it up into the two columns. So negative 3 comma negative 5. Split this one up, negative 2, negative 3. Those are both negative 1s, that's easy. This guy here will be a 0 and then a 1. Then we have a 1, then a 3. And I'm actually going to extend my table here because I didn't have quite enough room. I'm going to put that last point on 2, 5. That's the function. Now the function table can really help us to find our equation. Because if we consider here, what do you have to do to a negative 5 to turn it into a negative 3? Well, you add 2. What do you have to do to a negative 3, excuse me, to turn into a negative 1? Well, you add 2. What do you have to do to a negative 1 to turn it into a positive 1? Add 2. What do you do to 1 to turn it into a 3? Add 2. What do you do to a 3 to turn it into a 5? We add 2. Go over to the x values. What are we doing over here? Well, all we did was add 1. And then we added 1. And then we added 1. We added 1. And we added 1. So what's going on here is every time this goes up by 1, this instead goes up by 2. Every time this goes up by 1, this goes up by 2. So what we can say here is that every time this goes up by 1, this goes up by 2. So this is increasing by 2 each time. Every time I move one spot to the right, it increases by 2. So this number right here, since we're repeatedly adding it, repeated addition is multiplication. We're going to multiply by 2 in our equation. So in my equation, this is going to be 2x. We're going to multiply by 2. Now if we think for a moment, and I'm going to use a dry erase board here for just a second. If I've got x and I've got y, and right now we know we're going to do a 2x. So we have negative 3, negative 2, negative 1, 0, 1, 2. Well, if we do 2x to this, this is going to be negative 6. This would be negative 4, negative 2, 0, 1, or excuse me, not 1. 2 times 1 is 2. 2 times 2 is 4. So the trouble, though, is this number over here is actually a negative 5. This is a negative 3. This is a negative 1. This is a 1. This is a 3. And this is a 5. So kind of the last thing we need to consider here is what is happening as I move here. We know we're going to do 2x, but then what are we going to do to it after we've multiplied x with 2? Well, looking here, the positives is really going to help us. So what do you do to a 4 to turn into a 5, a 2 to turn into a 3, a 0 to turn into a 1? Well, it looks like we take all these values here and we're adding 1. So the last part of finding this equation, so we look at how these groups are changing, make a little fraction out of it, that's what we're going to multiply by. The last part is we're going to add or subtract to adjust it. So this part here, add or subtract to adjust. Now, ladies and gentlemen, if we take a step back here, we didn't do anything that complicated for this one. We could just see that we're taking all the x values and subtracting 2. If you can just see the equation, make sure you actually test it out and it works, but that's fine. If we go back to the front, we could tell that what we're doing here is we're just taking our x value and multiplying it by 2. Again, double check that it actually works, but if you can just see it, that's fine. But if we find ourselves in a situation where maybe this isn't so obvious, what do you do to a -3 to make it a -5? What do you do to a -2 to make it into a -3? What do you do to a -1 to change it, well, into another -1? What do you do to a 0 to make it a 1? What we're going to do, just to walk you through it one more time, is we're going to look at how are all the y values changing. We're going to look at how are all the x values changing. We're going to take those numbers, make a quick fraction out of it. Just to be clear, it will be the y value over the x value change. So how are the y values changing over the x values? This is the number that we keep adding. Every time my x value goes up 1, I add another 2. It goes up another 1, I add another 2. So I'm repeatedly adding 2. Repeated addition is multiplication. So this fraction, which comes from these changes, is what we multiply with x. Now, if this doesn't work perfectly, though, we're just going to add or subtract to adjust it. So in this case, all these were off. I needed to add 1 to get them all to work out. So my equation is y equals 2x plus 1. And that is lesson 56.